you had n sides you didn't know, how would I figure out the number of triangles that fit in there? 2 less than the sides. Okay? So I would take the number of sides and I would minus 2. That would tell me how many triangles fit in there. Okay? 3 sides, 1 triangle. 4 sides, 2 triangles. 5 sides, 3 triangles. We're just taking. So right, the number of sides, we subtract 2, and that's how many triangles can fit in there. Then we took that number and we multiplied it by 180. So if I want to know the sum of the interior angles, I'm going to take the number of sides minus 2 and multiply that by 180 degrees. Okay, so your paper should look like this. You got our 4 polygons. We broke it up into triangles. We see that the number of triangles were 2, 3, 4, and all we did was multiply by 180 to get these values. We multiply by 180 to get these values. So a general rule that's going to work for all polygons is this right here. And so this is the next thing that you need to write down. This is the, quote, general rule. And we're going to take the quantity n minus 2, and we have to remember that n is representing the number of sides. We're going to subtract 2, whatever that value is, then we're going to multiply it by 180, and that's going to give us, make sure you know, it's going to give us the sum of all of the interior angles. When we add them all up, 145, look at page 145 of your homework this evening. You have odds on this. It says, find the sum of the measure of the interior angles. Okay? When you're looking for the sum of the measures of the interior angles, that is n minus 2, the number of sides that shape has, minus 2, and you multiply it to 180. It's going to be a big number, because that's all of the angles added up. Every single time you add a side to the polygon, that means that's more and more and more degrees that those interior angles are going to add up to. Now let's talk about the exterior angles. Talk about the exterior angles now. First off, we need to know, how is an exterior angle created? And so you can write this down. We've seen this diagram before. We have a triangle, and we've looked at its exterior angle. And we said that we create an exterior angle by doing what? What is this thing? Yeah, you extend it, right? So you extend this side, and we extend this side, and make sure that you're extending in the same way. So I started here, and I'm going counterclockwise. And so now I've created X, Y, Z, and those are those exterior angles. Well, however many sides a shape has, that's how many interior angles it has, and that's how many exterior angles it has. So the triangle has 3 sides, 3 interior angles, and 3 exterior angles. Same thing with the quadrilateral. If I wanted to, I could create the 4 exterior angles. I'm going to keep extending them in the same way. You can only extend each side once. You can only extend each side once. So there are my 4 exterior angles, and I'll call them X, Y, Z, W. We can continue drawing diagrams like these, but in the end, it's very simple. No matter how many sides the shape has, when you are looking at your exterior angles and you need to add them up, all you're doing is just, so this is one exterior angle here, and you're going to add that to the next exterior angle, and you're going to add that to the next exterior angle, and you're going to add that to the last exterior angle. What did I literally just do? I just did a 360 turn. I'm all the way back to when I started. It doesn't matter how many pieces it's being broken up. If I add this and this and this, and I have to do that 20 million times, I'm eventually going to have to get back to where I started. And so the exterior angles of any polygon, the exterior angles of any polygon will always add up, will always sum up to be 360 degrees. So it's good to have those diagrams, but exterior angles. The sum of the exterior angles will always be 360 degrees, no matter the polygon. We should already know what an equilateral polygon is. If a polygon is equilateral, what does that mean?
All sides are equal.
All sides are equal. You can have an equilateral quadrilateral, you can have an equilateral pentagon, hexagon, octagon, whatever. It means all sides are congruent. It does not mean one specific shape. It does not mean one specific shape. It means that all the sides are congruent. We've already learned this and talked about this. What does equiangular mean?
All the angles are
All the angles are congruent of that polygon. However many sides it has, it doesn't matter. This is not talking about one specific polygon. It just means all the angles are congruent. Well, when you have both at the same time, we call that a regular polygon. So you can have a regular triangle, you can have a regular quadrilateral, you can have a regular pentagon, and so on and so forth. And that means regular means it is both equilateral and equal angular. You need to know what a regular polygon is. So knowing what a regular polygon is, below that we're going to start talking about the angles of some regular polygons. What if you had a regular triangle? You get a regular triangle, so I want you to go ahead and write. We're dealing with a regular triangle. If you have a regular triangle, let's talk about the interior angles. What do we know that the interior angles have to add up to be? The three interior angles have to add up to be 180 degrees. So what we're going to do is we're going to take the 180 degrees that the three have to add up. Well, if it's regular, what does that mean about the three interior angles that add up to be 180 degrees? What does regular tell us about the interior angles? They're all congruent. So if they're all congruent, that means this 180 degrees is going to be split up evenly. So if I want to know each individual interior angle, what am I going to have to do to this 180 degrees? Divided by 3. And that gets us 60 degrees. So if you're asked for each interior angle of a polygon, you take sum of interior angles, whatever that is, and we learned today how to find the sum of any polygon's interior angles, no matter how many sides it has. And we're going to have to divide that by n, the number of sides. We're going to have to divide that by n, the number of sides. But we also need to talk about the exterior angles. We need to know what each exterior angle of a regular triangle is. We're going to do the same thing. We know that there are how many exterior angles of a regular triangle? There's 3 of them. There's 3. Well, do we know how many degrees it's going to sum up when we sum up the 3 exterior angles of a triangle? Do we know how much that's going to be?
60.
Is that for just triangles?
For all polygons.
Any polygons. Any polygons. It doesn't matter. exterior angles are going to add up to be 360 degrees. Well, for a triangle, that 360 degrees needs to be split up evenly between these three exterior angles. So what is that going to make? 1. How'd you get 120?
Divided by 3.
Take 360 degrees, which is the sum of the exterior angles, and divide it by however many exterior angles there are. In this case, 120 degrees. I want you to do the same exact thing for a regular quadrilateral. What is each interior angle?
45 degrees.
What? What is the sum of the 4 interior angles of a quadrilateral? What is the sum?
45.
360 degrees. If you're using 180, you're dealing with a triangle. Okay? The sum of the interior angles changes. What happens as you add more sides? The sum gets bigger and bigger and bigger and bigger. So the sum of the interior angles is not 180. We're not talking about a triangle anymore. We're talking about a quadrilateral that has 4 sides. So 4 minus 2 is equal to what? 2. And 2 times 180 is equal to 360. So to find out, and you should have written this, the sum of the interior angles, you find that out using n minus 2 times 180 degrees. So what is the measure of each interior angle?
90.
90. What's the measure of each exterior angle? What is it? What's the sum of the exterior angles always? 360 divided by 4. 90. Okay. I want you to do the same exact thing for a pentagon. So what we're going to do is just right below this. Regular pentagon. I don't know if I just said that. I mean, that's not. Anyways, we're going to do it for a pentagon now. This will be the last one that we do together. But I need to know each interior angle of a regular pentagon. What is the sum of the interior angles of a pentagon? What's the sum of all 5? 540. Well, that's being evenly split between the 5 interior angles because it's a regular pentagon. So what is each one going to be? 1 what? 108. Good. What's the measure of each exterior angle? Huh? 72. I thought someone said something. 72. Okay. Now, what do you notice about the relationship between the interior and the exterior angle? What do you notice that's true for all of these examples? You don't see any patterns at all. What's 60 plus 120? What's 90 plus 90?
180.
What's 108 plus 72?
180.
180. So these are always seem to be supplementary. Is that just a coinkydink?
No.
It's not, because here is my, I'm going to put I for interior angle. If I want to know the exterior angle, I'm going to put E for exterior angle. What's this special pair of angles here?
Linear
A
pair.
linear pair. And linear pair are always supplementary, right? That means your interior angle in its x